sine function, that is sine in the range -1 and 1 within the closed interval. This is the closed interval. Then the range of cosine function -1 and 1 with the closed interval. Tangent function, that is x such that x is equal to 2n plus 1 of pi by 2, where n belongs to the integer. And cotangent, the range is x such that x is equal to n pi, where n belongs to the integer. So that is the range. Secant function, here, that is x such that x is equal to 2n plus 1 of pi by 2, where n belongs to the integer. That is, or excluding -1, 1 with the open interval. Secant function, cosecant, that is cosecant function, here or minus x such that x is equal to n pi, n belongs to the integer. So you can simply say or excluding minus within open interval -1, 1. Okay. Now let us try to understand these functions in terms of graphical representation. Now what does it represent? This graph represents y is equal to sin x. Y is equal to sin x. It means it is a sinusoidal wave, and that is why it's called sine of x. The lateral axis, that is x-axis, on the right side 0 to x on the positive side. On the left side you have 0, and here that is minus infinity. So in this case minus 5 by 2, here 5 pi by 2. So let us start. It starts from 0 and reaches the maximum. This is the crest where it is pi by 2. So pi by 2 means in terms of a circle this can be represented. Okay. Now let us draw a circle like this, and x-axis, y-axis, these are the 4 quadrants. Let me start from here. This is a 0, this is pi, that is 180. And what about this? In the second round this becomes 2 pi, is it not? So in the first circular motion we can call it a circular motion, and here 0 to this is pi, and here pi by 2. And what about this? This is 1.5 pi, that is 3 pi by 2 or 3 by 2 pi. And in terms of degree you can say this is 0 degree, and this is 180 degree, and this is 360 degree. So it makes one full round. And what about this? This is 90 degree. Pi by 2 means 90 degree, and this one 270 degree. Now let me go in detail. So when we say 0 to pi, 0 to pi by 2 means 0 to pi by 2. So it goes like this. Now 0 to pi. Are you able to follow? So 0 to pi by 2. So this is, let me say this is A, and it has reached B. So similarly, or you can put it as, okay, so let me put O here, and this is A, Similarly, this is O, this is A. So OA, it has covered 90 degree, and from 90 degree to, that is B position, and this is the B position. Are you able to follow? So that is pi, which is nothing but 180 degree. And here again it comes here. Okay, now let it go here up to 1.5 pi. So that is 3 pi by 2. Do you understand this? So let me say this is C. So this position is C, and here 2 pi. So 2 pi means it has come again to O, but it is in the second round, so you can put D. Okay, so you can call it D. So it means one full wave means starting from O to A to B, B to C, C to D. So it has made one full wave, that is the sinusoidal wave. Likewise, it is going to continue. Do you understand? Similarly, on the left hand side, so it goes here. So it has, as though it has come from minus 2 pi by 2 pi to, and here pi, minus pi, and here minus pi by 2. And what about this position? So this is opposite to this. Okay, minus 3 pi by 2. Okay, you can call it minus 3 pi by 2, and goes to minus 2 pi. So on both sides you are able to get. Okay, so this is called y is equal to sin x function. Do you understand? You may ask me, sir, that is, we are discussing only sine inverse function. Why should we discuss sine x function? In order to have a better understanding about y is equal to sine x, so that you can clearly understand. Now on inversing, so you are able to get this kind of graph, that is y is equal to sine inverse of x. Okay, so what about this? This is y is equal to sine x. What about this? This is y is equal to sine inverse of x. So in that case, you have got the x-axis and y-axis. So the wave is about the y-axis. Okay, so here it can go pi by 2, and then pi, and then 3 pi by 2 and 2 pi. Okay, so similarly, that is, you can mention A, O, A, B, C, and then D. Likewise it goes. And on the negative side also, if it is pi by 2, on the other side, negative side, it should be minus pi by 2. So you can put A dash. And what about this? This is B dash. What about this? This is C dash. And this one is a D dash. So at C dash, it is exactly negative to the 3 pi by 2. So minus 3 pi by 2. Do you understand? So this graph is represented as, that is representing y is equal to sine inverse of x. But you should understand very importantly here, that is, it can range in the x-axis between +1 and -1. Are you able to understand this? So this is ranging from -1 to +1. Okay, right. Let me combine this y is equal to sine x and y is equal to sine inverse of x. So this graph represents both. What about this? This graph represents y is equal to sine x. What about this? Here y is equal to sine inverse of x. Are you able to follow? And what about this linear, straight line? This is y is equal to x. Okay, so for a better understanding, you should be able to draw both diagrams. Okay, please draw this. Now let us see y is equal to cos x as well as y is equal to cos inverse of x. So here at the origin it starts from, that is 1 here, okay, and it goes to pi by 2, and in this case it is 0, okay. So here it is pi by 2, and on the y-axis it can go up to 1, and in this case minus 1, okay. So the interval is minus 1 to 1. In this case minus 1 to 1 along x-axis. In the case of y is equal to cos inverse of x. What about this? This is y is equal to cos x. So it starts from the maximum, and here reaches pi by 2, and here pi, and here. So likewise it goes, okay. This graph represents y is equal to cos x, and where it is symmetric about the y-axis, then that represents y is equal to cos inverse of x, okay. And in both cases you should find the interval of this graph is on y-axis minus 1 to 1, and the y is equal to cos inverse of x here minus 1 to plus 1 along x-axis. You know very well the reciprocal of sin x is cosecant x. So this is the reciprocal. For instance, if it goes like this, and you can have the curve that is representing y is equal to cosecant x. So here the lowest, the trough value is pi by 2, and here 3 pi by 2, okay. So likewise the y is equal to cosecant x is represented, okay. So try to understand this graph, and the origin is 0 here. So it can go up to, that is minus 1, minus 2 along the y-axis, and also plus 1, plus 2, etc. Okay, so it can grow along y-axis in this way, and on the opposite sides also along minus y-axis in this way. But it goes on x-axis as pi by 2, pi, 1/2 pi, 2 pi. Likewise the interval, it is pi by 2, okay. So here on the other side, that is left side, minus pi by 2, minus pi, minus 1/2 pi, minus 2 pi, likewise it goes. So when it is inverse, that is y is equal to cosecant inverse of x, then it is represented in this way, okay. You have to just tilt like this so that it is oriented along y-axis. So y is equal to cosecant x. So in this case, now the lowest value, the the minimum value is pi by 2, okay. So here it can go 1, 2, 3 on the right side, and similarly on the left side, minus 1, minus 2, minus 3, etc. Okay, on the along y-axis you have plus pi, then 1/2 pi, then 2 pi, and similarly here minus pi by 2, and minus pi, minus 1/2 pi, minus 2 pi, etc. So this graph represents y is equal to cosecant inverse of x. This graph represent y is equal to secant x. And what about this? This is y is equal to secant inverse x. So secant x is the reciprocal of cos x. So you would have found in the cos value, that is the crest starts from the origin. So here it is just reversed. So it is 1, 2, 3. So along the y-axis, it is something like a parabola with a opened curve at the top. So likewise it goes alternatively. So here it is at the bottom, here at the top. So likewise it is going to build up. And in this case it is symmetric about y-axis in the case of y is equal to secant inverse of x. Okay. Similarly, we can illustrate the tan y is equal to tan x and y is equal to tan inverse of x. So here tan x, that is y is equal to tan x, is represented in this way. So it goes here and sweeps to the bottom. Again it forms a tan curve, and here it goes via origin and sweeps to the left extreme and again forms a curve. So that is y is equal to tan inverse of x, and this one is y is equal to tan x. Similarly, cot x, y is equal to cot x. Here it is that is making a curve like this and immediately sweeps to the, that is pi at the top, and again comes down like this. So starting from, that is a negative, that is minus pi to pi here. So in this case it is symmetric about y-axis, and the same sweep can be observed here. Okay, in the case of y is equal to cot inverse of x. So try to visualize all these graphs of that is trigonometric functions and their respective inverse functions also.